Our universe is a big place. So big, your brain can't really comprehend it. Just our home galaxy, the Milky Way, contains up to 400 billion stars, and there are about 2 trillion galaxies in the observable universe. The numbers are staggering. For a long time, we didn't know if other stars had planets. Now we know, most of them do. Many of these stars have rocky planets in the habitable zone where liquid water could exist. Conservative estimates suggest there are billions of Earth-like planets in our galaxy alone. Our sun is also relatively young. Life on other planets could have started billions of years before Earth was even formed. If even a tiny fraction of these planets developed life, and a fraction of that life became intelligent, and a fraction of those decided to explore the stars, the galaxy should be teeming with civilizations. Even with slow, conventional technology, a single civilization could colonize the entire galaxy in just a few million years. So we look. We listen for their signals, their radio broadcasts, any sign of their technology. And we find nothing. No signals, no probes, no evidence of anyone. This is the Fermi Paradox. The universe should be full of life, but it appears to be empty. It's the profound and chilling question, where is everybody? There are many possible solutions to this paradox, and they range from hopeful to utterly terrifying. One category of solutions involves the Great Filter. The idea is that there's some step in the development of a spacefaring civilization that is incredibly unlikely or impossible to overcome. One possibility is that the filter is behind us. This is the hopeful scenario. Perhaps the jump from non-living matter to the first simple life is the filter. Life itself is incredibly rare. Or maybe the filter was the leap from simple prokaryotic cells to complex eukaryotic cells. This took over 1 billion years on Earth. If the filter is in our past, it means we are special. We won the cosmic lottery. But what if the Great Filter is ahead of us? This is the terrifying possibility. Perhaps almost all intelligent civilizations inevitably destroy themselves once they develop a certain level of technology. Through nuclear war, climate change, engineered pandemics, or an unfriendly AI. This would mean that discovering simple life on Mars would be the worst news imaginable. It would mean the filter is almost certainly ahead of us. But maybe the paradox has other solutions. What if intelligent life is common, but silent? This leads us to the dark forest hypothesis. The universe is a dark forest. Every civilization is a hunter, and you can't know the intentions of another. Are they peaceful, or will they destroy you to eliminate a potential threat? Because of the vast distances, there's no way to communicate trust. So the only logical survival strategy is to stay hidden. And if you do detect another civilization, you must destroy it first, before it destroys you. In this scenario, the silence of the sky is not because we are alone, but because everyone else is smart enough to keep quiet. A less terrifying idea is the zoo hypothesis. It suggests that advanced civilizations know we're here, but they deliberately hide themselves from us. They treat us like a protected nature preserve, or a developing species they don't want to contaminate with their influence. Perhaps they are waiting for us to reach a certain level of maturity before they reveal themselves. Another possibility, we are looking for the wrong thing. Our idea of life and technology might be hopelessly primitive. A sufficiently advanced civilization might be as incomprehensible to us as our civilization is to an ant. They might communicate using neutrinos or gravitational waves. They might be digital beings living in virtual realities. We wouldn't know how to look. Or the solution could be much simpler. Space is just too big. Even if there are thousands of civilizations, they might be so far apart in space and time that we will never encounter one another. A civilization might last for 100,000 years, but that's a blink of an eye in the life of the galaxy. The galaxy could have been home to countless empires that rose and fell long before we appeared, and will be home to others long after we are gone. And we have only been listening for about a century. We have scanned a minuscule fraction of the cosmic radio dial. Our search for aliens so far is like taking a single cup of water from all the Earth's oceans and concluding there are no whales. So, where does this leave us? With a range of unsettling possibilities. Either we are alone, the first, or tragically, the last. Or, the universe is full of life, but it is a dangerous place where silence is survival. The Fermi Paradox isn't just a puzzle about aliens, it's a mirror reflecting our own civilization. It highlights the immense preciousness of what we have here on Earth. If we are the only ones, we have a profound responsibility to survive and explore. The Great Silence is a warning. Whatever challenges lie ahead, we must be the ones to overcome them. The core of the paradox is that life, once started, tends to spread everywhere it can. A truly advanced civilization would be able to harness the energy of its entire star or even its galaxy. They would be hard to miss. We've looked for these macro engineering projects. We have found no evidence of them. Let's reconsider the Great Filter. The question is, where is it on our timeline? We are rare. The jump to complex, multicellular life was a 1 in a trillion chance, and we were the winners. We are the first. The universe is old, but perhaps the conditions for intelligent life have only recently become right. We are simply ahead of the curve. we are doomed. The filter is ahead of us and no civilization makes it past this point. The silence is a graveyard. A different idea, most life in the galaxy exists in subsurface oceans, cut off from the rest of the universe. They could have rich biospheres and even intelligence, but they would never signal their existence to the cosmos. What if advanced civilizations inevitably turn inward? They might create simulated universes that are more interesting than the physical one. Exploring the real universe is slow and dangerous. Why bother when you can create your own perfect reality? And we must always remember the scale. We have barely begun to look. The sky is vast, and our resources are limited. The signal could be there, we just haven't pointed our telescopes in the right direction at the right time. The absence of evidence is not evidence of absence. We simply don't have enough data to make any firm conclusions. So we must keep looking, keep listening, and keep wondering. The Fermi Paradox leaves us in a profound state of uncertainty. Are we alone in this vast cosmos? Or is the cosmos a far more dangerous place than we imagined? Either answer has staggering implications for our future and our place in the universe. It forces us to consider the fragility and importance of our own civilization. We might be the only chance for the galaxy to be aware of itself. For now, we are the only answer we have to the great silence. We must be a good one. Thank you for joining us on this journey into the great unknown. Your curiosity makes these explorations possible. If you enjoyed pondering the silence of the cosmos, consider subscribing to our channel, Capybrain, for more adventures into the biggest questions of science. Don't forget to ring the bell to be notified every time we explore a new cosmic mystery. From all of us here at Capybrain, stay curious. Thanks for watching. The truth is, we don't know which solution is correct. We only have hypotheses. The paradox perfectly balances our hope of finding others with our fear of the unknown, but it also fuels our curiosity and our drive to explore. With every new telescope and every new mission, we get a little closer to gathering more data. One day, we might find a biosignature in the atmosphere of an exoplanet. And that discovery will be the most important moment in human history, forcing us to reevaluate our place in the universe. Perhaps we're missing a key piece of the puzzle, some physical law or sociological principle we haven't discovered yet. The rare Earth hypothesis suggests the combination of factors that led to us is so astronomically unlikely that we may as well be unique. Things like having a large moon to stabilize our axis, and a gas giant like Jupiter to protect us from impacts. In this view, the silence exists because there's simply no one else to talk to. Revisiting the dark forest, this solution has gained popularity because it's strategically sound, even if terrifying. It assumes the worst, and in a game of cosmic survival, assuming the worst is the safest bet. This has led some to argue that we should stop broadcasting signals into space. That shouting into the jungle is a foolish move. For now, we continue to listen, but perhaps we should think twice before we shout. There are dozens of other proposed solutions, each reflecting our own biases and assumptions. The question of, are we alone, is one of the oldest and most fundamental questions we can ask. It connects us to our ancestors and will connect us to our descendants. In seeking others, we are ultimately seeking to understand ourselves. So, what is the solution to the Fermi Paradox? We don't know. But the question itself is what's important. It is the engine of our curiosity. It reminds us that we are all crew members on a tiny vessel in a vast cosmic ocean, and it's a journey we are all on together. The silence does not have to be an answer, but can be an invitation to learn, to explore, and to become a civilization worth finding. The journey is far from over. Another factor is time. The universe has existed for 13.8 billion years. We've been a technological species for only a couple of centuries. Civilizations may be common, but they might be separated by vast gulfs of time, never coexisting. The sky could be silent because we are listening in an empty moment. The galaxy might be a graveyard of fallen empires. The Great Filter could even be psychological. Perhaps intelligence always evolves with self-destructive tendencies. The same tribalism and aggression that helped us survive in the beginning could be our ultimate undoing on a planetary scale. What if their signals are too advanced? A compressed, perfectly efficient signal would be indistinguishable from background noise to a lesser species. They might be broadcasting all the time, but we are too primitive to even recognize it as a signal. The fundamental problem is that we are trying to solve this puzzle with only one data point, ourselves. We assume aliens would be like us, that they would want to explore, communicate, and build empires. This might just be wishful thinking. The universe could be full of intelligence, but it might be completely alien to our understanding of the concept. The estivation hypothesis suggests that advanced civilizations aren't dead. They are sleeping. They are waiting for a colder future universe, when the laws of thermodynamics will allow for much more efficient computation. They are playing the long game. Maybe the evidence is already in our data, but we are not smart enough to see it yet. Future analysis or artificial intelligence might one day comb through our old recordings and find a message that's been waiting there all along. Each possible solution to the paradox is a world unto itself with profound implications. Whatever the answer, the paradox teaches us one thing: the world we have is incredibly precious. Whether we are the only candle in the darkness or one of many hiding our light, our first duty is to keep our own flame burning. The search for others begins with the preservation of ourselves. If we are alone, the universe's potential for self-awareness rests on our shoulders. If we are not alone, surviving long enough to meet them is our greatest challenge. The paradox remains. The numbers say the sky should be full. The observations say it's empty. And we are left to live our lives in the shadow of this profound and perhaps unanswerable question. But in asking the question, we prove that at least one species is looking up and wondering. And for now, that will have to be enough. So, are we a fluke of nature, or are we potential prey in a cosmic jungle? The story of our universe and our place in it is still being written. The silence is not an end, but a challenge to our science, our philosophy, and our future. Every new discovery adds a piece to the puzzle, even if it makes the picture stranger. It is the biggest mystery we know, and we are lucky enough to be alive at a time when we can begin to investigate it. The universe is waiting, and we are just getting started. Thank you for exploring this cosmic mystery with us. Your curiosity is what drives us to ask these big questions. If you want to keep exploring the universe with us, consider subscribing to Capybrain, and ring the bell so you won't miss our next journey into the unknown. We have so many more questions to answer together. From all of us here at Capybrain, stay curious. What do you think is the solution to the Fermi Paradox? Let us know in the comments. This question is one of the pillars of modern astrobiology, the stark contrast between a universe that should be noisy and a reality that is silent. Thanks for watching. Our universe is a big place, so big your brain can't really comprehend it. Just our home galaxy, the Milky Way, contains up to 400 billion stars, and there are about 2 trillion galaxies in the observable universe. The numbers are staggering. For a long time, we didn't know if other stars had planets. Now we know most of them do.